In this video, we want to rewrite this definition of integral using integral notation. So let's start off with the definition. So the integral from a to b of x dx can be rewritten in this notation. So let's just compare this notation here with the problem that we have. It's best to start on the outside. So the outside is our delta x, which is 3 over n. Okay, so delta x is b minus a over n by definition, which in this problem is 3 over n. The n's are going to cancel, and we have b minus a is 3. Now, we're going to work inside. So I'm going to rewrite 2 plus 3k over n as 2 plus, and then k times delta x raised to the 4th power. Because delta x we said is 3 over n. Okay, so this is delta x. So it's 2 plus k times delta x raised to the 4th power. And now it's very easy to see what the input is. Okay, so we have k delta x, and then obviously a has to be 2. If a is 2, we have b minus 2 is 3, so b is 5. Now clearly the function has to be x to the 4th. So I'm inputting this, so this is my whole input. And what I'm doing is I'm taking my input and raising it to the 4th power. So if I put x in there, I'm going to get x to the 4th power. So whatever I put in, I get that result raised to the 4th power. So it's clear that my function has to be x to the 4th power. So now I have all the pieces. Recall that I wanted to form integral from a to b f of x dx. A is 2, b is 5, f of x is x to the 4th. Now this is one way of doing it. We can also do this a different way. And this different way depends on how you define f of x. Previously we said f of x was x to the 4th. But what if we took advantage of this 2? What if this 2 was part of my f of x? So what if we said instead, let f of x be 2 plus x raised to the 4th power? Does that work? Well, let's see. Let's plug in f of, and here, because we're letting my function be 2 plus x to the 4th, this 2 is already taken care of. So a has to be 0, and you'll see that in a second. So let's look at a plus k delta x. So we have 2 plus, and then a plus k delta x raised to the 4th power. Now, this what we said before was k delta x. We had the 2, so that's why a has to be 0. And so these two are identical. Okay, so now moving on, we know that delta x was 3 over n, so that didn't change, which means b minus a has to be 3, similar to this step right here. And so because a was 0, b has to be 3. And so we can rewrite this as the integral from 0 to 3 of 2 plus x raised to the 4th power. And that is our second solution.